All right, we're gonna go over the first questions. Who's want to volunteer for the answer?
The formula for molarity, right?
Yes.
I put M equals number of moles of solute over liters of solution.
Yes, or also known as V.
Okay.
Everyone got this answer?
Yep.
Yeah.
Awesome. The next question. What is the formula for converting to grams?
Gram mole times mole equal to grams.
You said gram mole.
Gram atomic weight.
Gram atomic weight.
Times mole.
And that equals grams.
Yes.
Everyone got this?
Yep.
All right, so question number 3, what is the formula used to solve dilution?
It's the M1 V1 equals M2 V2, right?
Everyone got this answer?
Mm-hmm.
Yes.
Anyone who didn't get the answer right, just mark an X to it. And at the end, we're going to be tallying up your scores. What is the formula used to calculate mole? Well, there are two. So what are the formulas used to calculate a mole? There are two of them.
I put molarity times volume for one of them.
All right, that's one of them. What's the other one?
Is it mass of a substance over the mass of 1 mole?
Mass of the substance, also known as what? What's the unit name?
I just marked it wrong.
Anyone else?
Is it grams over mole?
Grams over mole. To get mole?
No, sorry. Grams over the atomic mass or the Gn -1.
Gmol. That's the answer for both of them. It's grams divided by gram atomic weight, or also known as Gmol, and you get the mole. The G's cancel out. All right, so next question. Number 5, what is the formula used to calculate volume?
Volume equals mole over molarity.
Anyone got this?
Yep.
That's the answer. Volume equals mole over molarity. The other way is mole divided by volume equal molarity. And to get mole, we do molarity times volume. Or liters, if you.
I was gonna
understand
say,
it.
make sure it's your volume in liters. Because a lot of the questions have it in milliliters and you have to do the conversion first.
So those are the three for molarity. These are the molarity formulas. Volume equals N over M, N over V equals M, M times V or M times L equals N. All right, so question number 6. Who did question number 6?
It's 100 milliliters in a liter.
No. What is the
Milliliters,
formula to convert milliliters to liters? What are the formulas to convert milliliter to liters and liters to milliliters?
So milliliters to liters, you got to divide by 1,000 to get liters. And then the inverse, liters to milliliters, you got to multiply it by 1,000.
This is the formula, milliliters to liters, milliliter divided by 1,000. Liters to milliliters, liters times 1,000, you get milliliters. An example would be, if we got 250 milliliters, and you want to turn it into liters, we just divide by 1,000. And that changed to 0.25 liters. The other way, now let's turn this, we can turn this back into milliliters, just times it by 1,000. And he goes back to this, 250. My dogs are gonna bark, so give me a second. Hello?
Yep.
Yeah.
All right, so I wrote out question number 8. Sorry about that. My dog's bark.
Good question. We skipped 7 on purpose.
Oh, shoot, I didn't notice that. All right, all right, let's do number 7. Well, let's do number 8 right now. I just did it, and then we'll do number 7.
All right, cool.
Sorry, thank you for noticing. So let's match this. What would be N1?
It'll be your
Initial
initial.
molarity. Oh, sorry.
How many
No,
people
you're
say
okay.
initial molarity?
I agree.
I got 2, 3,
I agree.
4,
Yep. Agreed.
5. 5 people say initial molarity. All right. How many people? What was the other one? All right. So yes, that's the answer. All right. So what about M2?
Final molarity.
Anyone else?
Same.
All right. That's what it is. Final molarity. Now V1.
Initial volume.
And last one. Last option.
I know.
Final volume in liters, which is for the formula M1 V1 equals M2 V2. All right, so let's do number 7 because I didn't realize I skipped it. What is the formula for stoichiometry?
So it's moles given times moles desired divided by the ratio of moles given.
Moles given. You said times?
Yep. Moles
Times
desired
moles desired
divided by ratio of the moles given.
all right? And that will equal your moles desired. Did you get this answer? Did anyone get this answer? So this is the answer for the question number 7. It's moles given, moles desired, ratio of moles given, and moles equals moles desired. So, for example, I'm going to use a very simple formula. We all know this one. Oh, let me undo that. So to balance this equation, we just put a 2. So 2H plus O, H2O. For stoichiometry would be the ratios, which are these. And let me do this, change the color. So these are the ratios of moles. So the ratio would be 2, 1, 1. So that's the ratio of moles. Ratio doesn't mean that's what it actually is. It's just like an analogy that I tell everybody here is think of it like 2 items that you need as in a recipe to make the last items, to make the final product. I use the analogy of a motorcycle. Like this one here, you need 2 wheels, 1 body, and you get 1 bike. So that's the ratio. For every 2 wheels, you get 1 body of one motorcycle. For every body, you get 1 motorcycle. Add them together, you still get 1 motorcycle. It's a ratio. So when they say moles given, it's mostly like the concentration of how much potency of hydrogen is going to be there to create it. So it's 2 for this one. And obviously the JW for hydrogen is 1.008. Roughly just 1. So that's the answer for number 7. All right, so let's do number 9. How many grams of CH3OH is needed to make a 0.244 molarity solution in 400 milliliters of water? Anyone got the answer for this?
I do, but I don't know if anybody else has it.
I do. I
do.
don't know if it's right.
I do.
All right, so what's your guys' answer? I'm gonna write it here.
Someone else go.
I have 3.13 grams.
3.13 grams.
Yeah.
Oh, I have 3.03.
I have 3.12.
I have
3.12.
3.13.
Ours can vary depending on which periodic table you use because some
Yeah.
are rounded.
Oh, okay, so what periodic table did you guys use?
I don't round mine. I don't use the one that's rounded. That's probably
You
why I
use
got
the one-
3.13.
You used the periodic table, the one that the professor gave us?
Nope, I had already printed mine and it's not rounded, so
Okay, what about everyone else?
I use mine from the book.
which is
You used
rounded.
Which is rounded, okay.
Yep.
Yep.
You used the one from the book, Vincent?
Yeah.
Autumn?
I used the one he gave us.
The one he gave us, okay, and Hope?
Yeah, the one he gave us.
So that's not rounded. So that's the one that's not rounded. Okay. So I'm gonna separate it right here. And Henderson, you used the one from the book, you said, right?
Yes, I
He did, yeah.
Yeah, okay. All right. So
I'm sorry, does it
how would
help
we
if
start it?
we, oh, okay, I was gonna say, like, does it help if we walk through the problem and see how you solve it?
Yeah, how do we solve it? What's the first step we gotta do?
I convert my milliliters to liters and then find the mole.
All right, so we have 400 milliliters. So we
it's
want to change it to
0.4
liters.
liters.
0.4 liters.
Mhm.
Yep.
All right, so now we have it in liters.
And then I did, to find my mole, I did the molarity, so the value of M was 0.244 times 0.4.
And we get
and I got 0.0976 moles.
0.0976.
Mhm. And then for grams, I did 0.0976 plus my GAW.
What's the GAW?
So I got 32.04186.
What is it? Sorry.
32.04186.
18486.
04186.
Okay. 04186.
No. 32.04186.
Oh, gotcha. Okay.
Yeah. So multiply my mole times my GAW. And I used 3 sig figs and got 3.13.
What'd you get for the full number? What was the full number?
Hold on, I gotta redo it. I don't think I wrote that one down. 32.048. 32.04186 times 0.096. So my whole number was 3.1272855.
3.127.
285536.
All right. So you went to the 366, right?
Yeah, because 0.244 was 3, so I used 3 sig figs.
So
I can also do 3
be the 3 sig figs.
Huh?
Which will be the 3 sig figs?
I did 3.1 and I rounded the 2 to 3. It would be 3.13 grams per grams of CH3OH.
That's without using the rounded sheet.
Correct.
All right, Henderson, you got, is it almost the same thing?
Yes, except for her 32.0486.
That part, this part.
Yeah,
Okay.
I have 32.042.
Okay, let me see, hold on. 32.042?
Yes.
Okay. 10.0976. You get the same thing.
I got 32.042 also, but I just got a different, I don't know.
Yeah, that's why I didn't have my round off, so it would have been ending up as 3.1232.
I got 3.1272992. All right.
So wait, why do you multiply? Because I just didn't multiply.
Okay, how do we get grams?
I don't know, apparently.
Grams to mole. You gotta
All right, let me erase this.
okay.
I mean, if you want to explain it, go ahead. Oh wait, let me undo that. All right, that's what we need. All right, so we need I'm gonna write down what we have. Let me go back to the question. All right, this is the substance that we're working with, CH3OH. Okay, what they're looking for is grams. They're looking for grams. What we have is milliliters, and what we have is molarity. We don't have the mole. So it's 400. Okay, it's right here, 400. And we turn it into liters, so it's 0.4. And the formula for grams is mole times GAW, or the G mole. So we're looking for grams. We're trying to get this. We have the molarity and we have the volume. But how do we remember I asked you what are the two ways to get mole?
Yeah.
Yeah. So this is the one way to get the mole. You told me one of them, which is how do we get mole?
The molarity times the volume.
Molarity times the volume, right? And that's how we get mole. And we need to use that mole to get the grams,
Mm-hmm.
because the question is we need this formula in grams. We need to do you can use a periodic table. We have to use a periodic table to get the elements,
Mm-hmm.
and you got this, and we just times with the mole from what we get doing the molarity times volume, the 2.44 times 0.4
Mm-hmm.
equals that. So that's why we get n. That's why we need the n. It's a converge. It's like how we did in the last test. We had to change. We had to go from grams to AMU to moles. Just pretty much the same way, but this time it's with liquid.
Okay.
You go from liquid to solid.
Okay.
Do you understand? Or
Yeah.
you got it? You sure?
Yeah.
All right, cool. Next question. What is the molarity of a solution with a mass of solute, 10 grams of mass, and 100 liter volume? So we're looking for the molarity. We're at grams and we have liters. So who got the answer to number 10?
0.1 molarity.
We got 0.1 molarity.
Yeah.
Anyone else? Okay. All right, so let's see how we got 0.1. What's the first thing we gotta do, Hope?
I divided the moles from the volume. So
How do we get the mole?
not the mole, the wait.
No, you're right, but how do we get the mole? So what they're looking for? Oh, just doesn't
I
say
don't
what
know. I did this, but
So,
I don't
all right,
know.
so I'm gonna write it here. I'm gonna write, hold on, let me see if I can write it there. So I'm gonna put G for grams. That's the mass they want. They want the volume, they want the molarity, and they want the mole. So what do we have? We have the grams, which is 10. And then we have the volume, which is 100 liters. So we need the molarity. They're looking for this, but we need this.
Yeah. I did this wrong.
Anyone else want to go a shot at it?
So for this, we have to convert grams to moles first.
Anyone but Seljani?
I agree with her.
No, yeah.
Okay, so yes, you have to convert it into moles. How do we convert into moles? Hope?
Oh no. Why are you asking me?
Practice.
Um,
To get moles.
get moles. Wouldn't it be grams over grams per mole?
Yeah. Oh, I see what's going on. There's no substance.
Yeah.
I just realized that there's no molarity on this one. I
No, there's
mean,
no
not,
substance.
there's no, yeah.
How I missed that? Oh my God. All right, so I guess number 10 is a dud. Sorry.
Let's see.
Number 11. All right, so number 11 was everyone was having problem with, right?
I didn't have 10 or 11.
Sorry, I'm looking up where I got 10 from so I can.
All right, so but 11, everyone had a problem with 11, right?
Yes, but I figured out how to do it actually.
Yeah, we went over it a little bit before.
All right, so
We
what was
can
the
go
answer?
over it again if you want.
It's up to you guys. If you guys got it, then I'm move on to the next. If not,
We
I mean,
should
I
go,
understand it now.
Yeah, I
should
got
go.
it, but if anyone else needs, then
Yeah, definitely.
Can you just go over it one time? I'm sorry.
all right, no problem. Yeah. So I'm gonna write here for solution. We have the V, which is 10 liters. And the other one is molarity, which is 4. The second solution is 40 liters. And molarity. And what they're looking for is molarity of both of them. All right. So what are we missing in these three formulas, in these three solutions?
The molarity?
We have it.
Oh, I'm sorry. The milliliters, don't we have to convert it?
No, they're already in liters.
Fuck. I'm sorry.
What we don't have is this, the mole. We don't have the mole on each. Josh. Because to get the molarity, we need volume and moles. When it comes to this, for these questions, ignore what the professor said about some mixtures cannot mix. When it comes to volumes, they always add together. So the first part is going to be easy. 10 plus 40.
50.
So we will have a total of 50. So that's what we have. So this is the V part is easy to get. Now all we need is to get the mole so we can get the molarity. The molarities cannot be added. That's the thing. V plus V can be added, but not M plus M.
Mhm.
Can we add it all at the end though, instead? Or does that give you a different answer?
The molarity,
No, the volumes.
the volume could be added.
I know, but so the way I was doing it was I would do solve the first one, then solve the second, and then add it.
Oh yes, in the end we
And then
add the moles.
add the end product.
Yes, the moles get added in the end.
Okay.
So these are only two that get added, the volume and the moles, never the molarity.
Right, but I'm saying if you add the volumes now for your formulas, you're gonna have 50. It's gonna give you a different figure for each solution.
No. We're doing the final solution.
I know, so wouldn't you add everything is at the end?
You don't add the moles, I mean, the molarity.
Okay, do it, continue doing it, and then maybe my answer that I got is wrong.
So the only thing that gets added to the final solution would be volume plus volume. You get 50 milliliters of volume. Moles and moles can be added together to get the final solution. But what do not get added is the molarity, because molarity is a concentration of water with the substance.
Right,
So that means we need to get the molarity, the moles for the first solution. How do we get that?
so I was doing M, which is 4 times 10. 4 times my volume.
So
And
that
then
would be
on the
40.
other side, so 40, and then on the other side, 80. 2 times 40.
All right, so for this 2 times 40 is 80, 4 times 10 is 40. We add them together. That would be
120.
120. So we got to divide.
So now we would divide 120 by the 50.
Yep.
Okay. So I stand corrected. When I first reviewed it, I was doing find the mole, the molarity for the first solution, then for the second, and then adding it, but that would give you a different number, I think. 50, 120 divided by 50. 2.4.
Anyone else got the same answer?
Yeah.
Yes.
Yeah.
So that's what we do. That's just basically what it's telling you is mixing A, mixing B to get C. This is color red. This is color yellow to get orange. So the molarity is the concentration of red. The molarity of 2 is the concentration of yellow. You mix the two together, and it's a 2.4 molarity of orange.
Got it.
All right, so let's go to the next question. Am I going too fast?
No.
Nope.
All right, so number 12. Let's do number 12. What are the correct coefficients when this chemical equation is balanced? So how do we balance this one?
We can set our little chart to the side. So it's P equals 4, O equals 2.
You said what?
P equals 4,
Oh, okay. So P equals 4.
O equals 2.
All right. This side.
And yeah, other side is P equals 2. And O equals 5.
All right.
So I'm gonna start in my right side. O is 5.
In the 5.
No, in the opposite side. Sorry.
All right. O is 5.
Well, I started from the other side because I started with P. I looked at both of my P's, so I knew that one P was 4. So I started with 2 times. I put a 2 in front of the P2. No, the opposite side. Sorry. Yep. So I went down to my little chart. So I went 2. Yeah. 4. And 2 goes over to 5. It'll be times 10.
Times 2,
Oh,
not
Oh,
10.
sorry. Yes, really. I see that. I meant 2. 5 times 2.
Yeah,
Equals
5 times 10. So just by looking at my O's, I knew I had to put a 5 in front of the, on that one. And then my equation is balanced. So it'll be P4. P4.
Oops. Wait, hold on. P4 equals 4. And then we got O and equals 10. So there we go. That's
So-
how it's balanced.
So yeah, exactly. And then I
So the
wrote
answer-
it. Yeah.
The answer is this: P4 5O2 2P2 5 05.
Yep.
I have a question.
Oh, Go for it.
Is that chart thingy like necessary? Like, do I have to do that thingy?
you don't have to do it this way. You can do it your own way, whatever is easier for you.
Oh, okay, cool.
This is the way I do it to show. My chart is, I use a different chart. You want to see the chart I use? It's
Sure.
long. It's a long chart.
Oh, then no.
All right, so next question. 13.
That one was a little bit tricky.
We got AL
AL, FE,
plus FEO to FE plus AL2O3. All right, so I'm gonna use my strategy since I'm here, since I'm doing this. I'm gonna do this one. So what I write, I do this and make a chart of the elements that we have first. FE and O. We have one AI times one here, so I'm gonna put it in a different color so we can see. Wait. This number affects all the other numbers.
Hi.
Hey, Manny. So that number affects all of these numbers. So right now I have one in each. All right, and for the other side, there's only one FE. 1 times 2. 1 times 3. And then I just compare these two numbers. 1 does not equal to 2. 1 does equal to 3. 2, 1. And 1 does not equal to 3. So right there, I can see what is unbalanced. The aluminum Al and the oxygen. How do I balance it? So right there, I have to figure out. I will start going to the next number, 2.
Gonna put
So right here, it will be easy. I have a 2 Al here. So that means I just got to put a 2 over here. All right. So 2 times 1 is 2. 1 times 2 is 2. So that's balanced. But then I'm looking at my 3. So I'm like saying it's an odd number and we can't make a 3 over here. Well, we can. We can. I just put a 3. So that means 3 times 1 is 3. 1 times 3 is 3. And then I deal with this. 3 times FE. All I got to put is another 3 here. So now it's balanced. And how do I balance it? I rewrite the thing over. AL, FE, O. I do So over here is 2 times 1 equal 2. 3 times 1 equals 3. 3 times 1 equals 3. Now on this side, 3 times 1 equals 3. 1 times 2 equals 2. 1 times 3 equals 3. So in the end, I see 2 equals 2, 3 equals 3, 3 equals 3. And they're cell balanced. 2AL. Let me restart. 2AL plus 3FeO equals 3Fe plus 1Al2O3. That's what I use. That's my chart that I use to solve to balance these stuff. Did that help, Anderson?
I still use my other chart. I figured it out. I used the other previous chart.
No, that's fine. You can use whatever chart, whatever is easier for you. I'm just showing what I use.
Yeah, this one is much better. I like this one.
All right, so I'm gonna do one more of the
You
balance.
already,
I'm
you
sorry.
already do number 9, 10, and 11.
Yeah, we're up to number 13.
Oh, is that
So number 10 though, you can disregard because it's missing something from the question, so don't do
Okay.
10.
Yeah, we ignore
Okay.
number 10.
okay.
All right, so I'm just gonna do one more of the balancing equation, and then I'm gonna skip on to the next one because there's like so many of them. Unless you guys want me to go over all of them.
Does anyone not understand how to balance?
I think you could skip forward.
You guys want to skip it? Skip all of them?
You can still do them and send them. You can, if you guys want to send them back in an email.
Yeah,
For
and
it
I'll
to be
grade it.
checked.
If you want me to grade
And
it and
then-
check it, I can do it. Yeah. All right, we're voting to skip it, or I'm gonna do the next number 19.
Sorry. Do you want to do one that has the parentheses?
Yeah, I'm gonna do
Like,
number 19.
Okay, perfect.
All right, we're doing number 19.
You guys probably hate me for this test. It was
Mm-mm.
hard.
Oh, that's a big one. This looks like a question from the textbook. Did you get a question from the textbook?
I did not.
Definitely it is.
It definitely looks like
This-
it though,
This is
but
the
I did
exact
not.
same one.
I can't squeeze
We
it in
didn't do
there.
any of this difficult in class, right?
In
The
class,
textbook
yes.
the textbooks was a little bit annoying though.
But he just doesn't explain this. I did not understand this when the professor taught it. I explained it when Professor David taught me.
All right, so let's balance it. Everyone got the answer, or we should go over it right now?
You should go over it.
All right. So on this
Do you
side,
just oh,
you were saying, yeah, go ahead.
do you distribute the numbers into the parentheses or no?
Okay, so this one here is count as one element.
So like for the SO that you just underlined before, so would it be like the O would have 12 because you multiply it by 3 or no?
No, it's three of these together.
Oh, okay.
Yeah, for this question, that's what I see. That's what I find. But the other question is not like that. The other question is the way that you were saying that's how you do it.
So for the other one, S would be times 3 and O would be 3 times 4, for example.
Yeah, for the next one will be like it says PO to PO4 and there's a 2 outside. So it'll be P times 2 and O4 times 2. So 4 times 2.
So what makes 20 different than 19?
The SO4 repeats on this side. The other one
Okay.
does not repeat. You see how the PO does not repeat?
Gotcha. Okay. See, that would have confused the heck out of me on the test.
So that's the first thing you gotta look for. If you see something in parentheses, make sure it repeats on the other side. If it doesn't repeat, then yes, this element is separates. But if it repeats like that, then it's together.
Got it.
All right, so I'm gonna write it on here. And do my chart. I'll explain, or I don't know if you guys get it. I'll explain it. Just let me write it out. Yeah, no, that's it. And they're all balanced. Can you guys see it?
Yes.
All right, so that's number 19. F2 parentheses SO4 close parentheses 3 plus 6KOH to 3K2 SO4 plus 2FE parentheses OH close parentheses 3. So that's the answer for question number 19. All right, we all set? We got it?
Yep.
Everyone understands? Hello?
Oh, sorry, yeah.
All right, moving on. Let's do 22. Balance the following equation and solve for each of the following. So what is the answer for number 22?
So for the balance equation, I got AL2 plus H6CL6.
Hold on. You said what? AL what?
AL2 plus H6CL6.
ALC2, okay, 2 ALC, H2, 3. Wait, let me give you a different color.
I got AL2 plus, wait.
That's what you
I
said,
don't
right?
think- Yeah,
So 6AL plus 6HCl, you get 2A, 2ALCl3. That's what you said?
No, it's not good.
no.
Not 6AL. It's supposed to be 2AL.
2, right.
2, okay. Sorry, 2AL. And HCl?
6.
6.
6. Okay. All right, cool. So now that's the balance equation. What's the answer for A?
So A, I got 9.0 times 10 to the negative 3 grams. I don't know. Well, I
9
don't, are you supposed to convert the grams like that?
Yes, we got to convert it to grams. This is a stoichiometry question.
So this is using the ratios.
Yep.
No.
What's the ratio
Okay,
here?
never. 2, 6, 2, 3. I told y'all I would fail my own test. I definitely didn't apply that formula.
I don't understand the ratio part of it.
We're gonna do it right now.
Okay.
So it's like what I told you before, when it comes to constructing stuff, analogy, like I said, the ratio of 2 wheels plus 1 body plus 1 handlebars, you get 1 full motorcycle.
Mm-hmm.
So this is like you need 2 moles of aluminum, 6 moles of hydrochloric acid, and you get aluminum, what is it? Aluminum chloride with a release of hydrogen.
Mm-hmm.
So basically it's like the experiment that we did yesterday.
But Hope, so you see how we just did the balancing where we put the coefficients?
Yeah.
So basically you had to do this, apply the same to this. And now your coefficient becomes your ratio number.
Right. And how do you use that in the division?
So that's where you apply the moles given times the moles desired divided by the moles of the ratio given.
Right. I'm confused now.
Okay, so I'm gonna write it
Okay.
up here.
Right. I
Moles
know what the
of-
formula is. I wasn't confused until like a minute ago.
Yeah, like how do you put the ratio into the formula?
Yeah, that's what I'm asking pretty much.
So you're asking where are we going?
Yeah, like the n given is the 3.33, yeah, that you wrote, and then you multiply that by desired over ratio.
Right.
So here's what it is. We have of AL. Let me write AL. So it says 3.33 moles of AL. So the element we're starting is with this. It wants to find grams of aluminum metal. So just the grams by itself. Oh no, it wants to find the aluminum chloride. Sorry, I'm reading it backwards. This is not, wait, this is AlCl. So it's here, we're starting here, and it wants us to go here. So the ratio would be from here to here, 2 to 2 ratio.
Just
The
means
numbers are
one.
the numbers are like are your destination A to destination B. So depending on what the question is asking you.
And your
The
ratio
question-
starts from where you're given.
Yes, which is this one, hydrochloric acid, aluminum chloride. And that's what we have here, the moles. So we're going to convert this moles into here to see how many moles are in aluminum, and then we're going to convert the aluminum into grams.
Just another note, because I confuse this all the time. When we're doing the ratios, the number given are given moles of AlCl, that ratio is going to be your numerator. Wait,
All right,
Is
so
that
I'm going to show you the 2 ways. There's 2 ways to that we do this. I'm going to show you the easy way, and I'm going to show you the way that the professor wants us to do it. Everyone knows how to do the professor way, so I'm going to show you the easy way. All right, so put it here.
But the number given is your numerator, right?
Yes, yes.
Okay. So in this
So
case,
ratio is 2, 2, or in other words, aluminum, wait, mole 2 equals mole 2. This side is the aluminum HCl, and this is just aluminum. So that's what the ratio means. This equals to this. So, but we already have this. So it's going to be N over 2 equals 3.33 divided by 2. So we have to get N by itself. How do we get N by itself? When you have two fractions between an equal, what do?
Cross multiply.
Cross multiply. So that'll be 2 times 3.33. That equals what?
6.66.
The devil's number.
Oh, yeah.
And then the other one is 2n, 2 times n, which is equals to n. So now that we have the n on one side and this number is condensed to 6.66, what's the next step to do to get n by itself?
Divide.
Divide. Divide by 2. The 2 cancels out. 6.66 divided by 2. What do we get?
3.33.
3.33. So that means aluminum here is the same ratio as the aluminum chloride. 3.33 moles.
In the way of the professor.
Well, Hope, do you get it now?
I have a question because I got that answer, but I don't know if I did it the right way.
No, this is the easy way. I can show you the way the professor.
Well, you showed me a way like last week, and that's what I did.
All right, so I guess you know the professor's way. So I'm gonna show you that one way. This is one way to do it. I'll
I
show you
don't
the
know.
other way. I'll show you the other way.
Okay.
Hope you always get the answer.
But
No,
I
you
don't
always
know
get the
how I got the answer. That's the issue.
It's like it just magically makes sense. All right, so let me do the other way. So what is the most given on this side?
3.33.
3.33. That's the mole given. Mole of AlCl. And then we do time mole desired, which is this, 2 mole of Al. Then we divide it by the mole ratio of what we're given, which is here, 2 mole
Yeah.
of AlCl3. And that equals to the answer that we got, 3.33.
Oh, that's how I did it.
Wait, the denominator, why is it 2?
Because that's the one that the ratio given. That's the one that we found out when we balanced it. That's what we found out when we balanced the equation. You get it or no?
It's like a 2-to-2 ratio, you mean?
Yeah, it's a 2-to-2 ratio.
But 2-to-2 ratio equals 1.
Exactly.
But then if that equals, oh, like the numerator and the denominator are the ratio.
Yeah.
Okay,
Yeah.
yeah. My bad. Yeah, okay, that makes sense.
Sorry. I didn't know that's what you meant. But yes, that's what we do. These two cancels out right here. You're left with this, which goes over here. Just solve the problem, just do the equation with the numbers. This times this, then divide by this, and then we get this.
So it was just the given times the aluminum ratio.
Yep,
Okay.
but we're not done yet. That's what we
Okay.
just now got the mole.
Yeah.
Now we're at aluminum, and the question wants us to find it in grams. What's the next step?
So for the grams, you multiply the mole times the GAW.
So what's the GAW of Al? Our mole is 3.33 times, what's the GAW
Of AL.
of Al?
It's not ALC1 we have to use, no?
No, we're not on here. We're over here.
26.98.
26.98. That's the GMO, right?
Yeah, wait, why are you using aluminum?
What's the question asking?
Oh, how many grams of aluminum? Okay.
You guys remember how elements, what are the elements, right?
Yeah, so where AL equals 26 point
No, no,
whatever.
the names of the elements, this here.
Oh, I no.
Because this is one element, this is two, this is two, and this is one.
I don't remember all of them. I remember the ones we normally use, like CL, H, O, C.
Right there, that's aluminum, hydrogen, chloride, aluminum.
Because you see, the question says we have 3.33 moles of aluminum chloride. So this element here is aluminum, this element here is chloride. So the name is just together, aluminum chloride. And it wants us to find aluminum, so without this, just this.
He probably won't give it to us on a test like that, right?
No, I just want you guys to recognize the name of the
No,
element.
no, no, I know. I'm just saying, like, he's probably not gonna give it to us, because that will take me a million hours to figure out.
I don't know. But it still has to deal with stoichiometry conversion. This is still stoichiometry. So what's the answer to this question?
89.8434.
39.8434.
No, 89.8434. Sorry.
34. No, it's all right. Okay, and how many sig figs do we have?
3.
3. So then it would just be 89.8 grams. That's the answer.
Oh, don't forget to put on the unit for 3.33. Yep.
The N? Oh yeah.
Yeah.
These are the units.
Forgot about that.
Yeah, I forgot about it too. Thank you.
Thank
So,
you.
so letter B is pretty much the same thing. B will be pretty much the same thing. So just let me erase this.
See?
B, the next question, the next part. All right, so the question is saying how many moles of hydrogen chloride are needed to react with this number of moles of aluminum metal? So I guess it wants us to use the moles that we have from the aluminum metal.
That's what I used. Because I didn't know what to use.
Yeah, because I think we're using all the same figures. That's all
Yeah.
considered one problem.
Honestly, I
Okay, so
think
yes, it is using it. It is using it. So I gotta rewrite this. Let me rewrite this. This is what's the first one we have? AL, CL. That is
I have
3.33, right? And
I'm
then
gonna sorry, I'm gonna get off. I have to go pick up my son. I'm gonna stay on the chat and I'll be back in like 15 minutes.
all right, no problem.
question, David. Don't we need
Yeah.
to add both of the atomic numbers of the first one, like aluminum chloride? So it'll be 26.98 with chloride of 35.4, then multiply it.
You mean you want to multiply this with this?
For the atomic mass, where I got the 26.98 prior problem that we did, then we had to add both atomic mass, like aluminum and chloride together, then multiply by 3.33. It's just a question.
I'm confused on what you're asking. You lost me. Sorry.
Yeah, sorry, I got confused for a second. Continue, I'll figure it out.
Are you sure? Because I can go over it right now. Again, I'll try it one more time.
No, it's possible. I'm good. Thanks.
All right, so it wants us to move to HCl now from here to here. So now the ratio is what?
2 and 6.
2 to 6.
Yeah.
That's the ratio, 2 to 6. I'm gonna put it over here. So which way you guys want me to use? The easy way or the other way?
And the exam, do we have to do it the way the professor show us or our way?
I think he would like it the way that he did it. He wants to see the units.
Oh, okay.
But I can do it both ways, whatever you guys easier, just as long as you know how to do it.
Professor's way.
All right. So what's the first thing we got? What's the first thing go here? What goes here?
The 3.33
3.33. Of what?
moles of aluminum.
Yeah.
All right.
Yeah.
Times
6/2.
6 moles HCl divide by 2 mole of AL. All right, and that equals?
It's like
9
nine, 9.
Go ahead, Hope.
9.99 moles of HCl.
9.99 moles.
Yeah.
All right, so that's your answer for B. I will skip number C because I don't think he's going to ask us that question about turning it into atoms. I think you guys know how to do that one, right? How to turn it into atoms? No? You guys forgot?
Avogadro's number
There you go.
times the mole.
And that's how we get the atoms. So we just have the moles, we just need to times it with Avogadro's number, and then boom, you get the atoms. That's how you solve the answer C. All right, so you guys got this done? I can erase it.
Yeah.
Yeah.
All right. All right, so it's pretty much the 23, 24 is repetitive. You guys understand it, want me, or I'm gonna skip to number 25.
25.
25, everyone else got it?
I'm good to skip.
All right, cool. So then we're doing 25. It says here, if you dilute 175 milliliters of 1.6 molarity solution of LiCl to 1.0 liters, determine the new concentration of the solution. So that's involving dilution, the dilution formula. You guys remember the formula?
M1 V1, M1 times V1 equal to M2 times V2.
Yep. So what's our M1?
M1 is
1.6.
yeah
1.6. All right, and our V1?
1
0.75.
One, you said
I said-
0.175?
Yeah, because I converted it to liters.
Good, that's what you're supposed to do. Awesome. 1.75 liters. This is M. Okay, and then it equals to, we don't have mole, we don't have the molarity, so that we put an X there. But we do have the volume for this one, and it's 1.0 L liters. So how do we solve this?
You gotta get the liters together.
Nope, not yet.
So then you multiply.
Okay, fine. We get the liters together, right? How do we do it?
You divide 1.0 0 to the, yep.
All right, so this cancels out, and now we're left with this. Oops. What would be the answer?
Point 28.
So the answer is 0.28. So M2 is 0.28.
So I have
That's
a
it.
question. I have a question for that. Do
Yeah.
we need to put the units like ml when we dividing and multiplying, or just leave it like this?
This formula only works if you turn it to liters.
Okay, cool.
You always have to turn it to liters. Depending on the question, if the question is asking you to change this to milliliters, then yes, we change it to milliliters in the end.
All right.
But the question is not asking you to do anything about the volume. They give it to you. So that was like a little trick.
Not trying to lose points.
All right, let's do number 27. That's pretty much what you're asking for right there. So I'm gonna write the list. M1, B1, M2, B2. All right, for number 27, what's our M1?
Point 1.2.
What? Number 27.
Oh, 20 set, sorry. .50.
No,
No, I'm sorry. I just reread the question. It's you have three things in there. Okay, so I'm gonna put M3. B3. Okay. So for this one, it's saying what volume of 4.50 molarity of HCl can be made by mixing of 5.65 molarity of HCl with 250 milliliters
So
of 3.5 molarity of HCl.
M1 is 4.50.
No, M1 is 3.55. Because we're mixing 250 milliliters of 3.55 molarity with 5.65 molarities of HCl. The last solution, M3, is 450. So we have M2, which is 5.65. And our volume is 0.25 liters. In milliliters is that's what you get in milliliters. 250. So first we got to do is we have to find the volume here to get the volume down here. Remember what I told you when you get two solutions and you add them together?
Yep.
What you can add together and what you can't add.
You can add volume.
Volume can add volume.
And molarity.
Molarity cannot.
No, sorry, I mean moles. So that's what I meant to say.
Moles you can. So volume 1, volume 2 equals volume 3. Mole 1, mole 2 equals mole 3. Molarities cannot, because how do we get molarities?
Multiply or divide.
That's the only way we can get molarities. That's why it cannot be added. You divide the moles of your solution by the volume of your solution to get the molarity of the solution. All right, so going by that, so let's find the V2.
I'm back. What
Welcome
number
back.
are we doing?
Number 27.
Hello?
All right, what do we do next?
Multiply.
What are we multiplying?
What?
What are we
Oh, I
multiplying?
multiplied the well, where's my thing? I don't even know where it is. 27. The 3.55 by the 0.25.
Yes, you can always start. That's the easiest way to start. I always recommend that way. Wait, no, we don't know the answer yet. Just that. All right, what's the next step?
Divide
What are we dividing?
by 5.65.
All right, X equals
0.151079. And then I stopped there.
0.150, you said?
151079.
You divided, but hold on. Let me see.
Did I
maybe
not
I'm-
get it right?
No, maybe I just typed it wrong. Hold on. I think I typed it wrong. Trying to see where, okay. We did
Oh.
0.8875 divided by 5.65.
Wait, 1.157.
No,
079.
yeah,
Yeah, that's the one, yeah.
There we
Okay.
go. I just can't read my handwriting.
I thought I got it wrong. Okay. So the answer, I'm gonna write it out the whole thing, 1.157 0.79646. All right, so what's the questions asking us? What's the volume? And we're working with milliliters. So we're gonna use how many sig figs? We're in liters right now. So we gotta change this to milliliters. And our liters here is 2 sig
Yeah.
figs. So what
We
would be
divide
the answer?
almost
0.16.
0.16, yeah. So that's our V2. 0.16 liters. But now we gotta change this to milliliters. We can change it now, we can change it later. It's up to you guys. I say leave it the way it is because the next step to do that is we gotta find number 3. And how do we do that?
You just add the two together, right?
Yeah, that's it. Just add them together. Nice job. .25 plus 0.16 equals what?
I got 0.401.
0.41, yes. But it is in liters, but the answer is they wanted it in milliliters. So now we can convert it. How do we convert it?
You multiply it by 1,000.
Yep. See which will get you
401 liters.
You got 401,
Yeah, what'd you get?
0.25 plus 0.16, no?
Wait,
I got 0.41.
wait, what are your numbers?
0.25 plus 0.16, 0.41.
Oh, I didn't round.
Yeah, and then there's no rounding. It's straightforward.
You said 16. I'm con-
0.16.
I don't know. Where'd you get the 16 from?
When we did the dilution, the M1V1, M2V2. When we did the thing before, I just erased it.
Gotcha. Okay.
I erased it. Remember you did the you multiplied the 3.5 by 2.5 and you got what was the answer?
Yeah, it was 157,079.
Yeah, 3.55 times 0.25.
0.8875.
Yeah, 0.8875. That we got that on this side, remember?
Yeah.
Right. And on the other side, we only had molarity, which was molarity times the unknown, which
Oh,
we didn't know it was X.
I see. You
We
did.
divide that, and then we get 16.
I see. I see. You did. Okay. 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 I see now. Okay. Carry on.
No, that's it. We really, and in the end, that's what we did. We just add them together. It became 0.41.
Okay.
Turn into milliliters, it'll be 410. So you see, Henderson, this is what I'm at. This is the question that you had, right?
Yeah.
Like when I'm going to turn into milliliters, when it depends on what they're asking you. This one
Okay,
was a
cool.
trick question.
Yeah.
There were three solutions in there. You have to, yeah, you got to read the questions and throw you off like that. All right, let me see here. You guys want to do another one of these? Or move on?
If you guys don't mind doing one more. Which
I
one did you just do right now? You did
27.
27. Okay.
Let's do 29. Here's the first question. How many solutions are there?
3.
Right? There's 3 solutions. So that means you have to do the M1, V1, M2, V2, M3, V3. Okay, sorry. So what do we have here? Two liters of 0.45445 molarity of HCl. You add 3.88 liters of a second HCl solution of an unknown concentration. We don't know the molarity. And the result solution is 0.974 molarity. Assuming the volumes are additive, calculate the molarity of the second HCl solution. So they want us to find what's the molarity of M2. So what do we have?
We have M1,
What's M1?
0.445. We have B1 is 2.0 liters. V2 is, we need M2.
I'm gonna put this X as X.
V2 is 3.88 liters. We have M3, which is 0.974.
Put this as Y.
And V3 is unknown.
This question is supposed to throw you off, but it's very simple if you can catch it. Did you guys catch it yet?
Yeah.
All right, just guys do it and tell me the answer, and then we go over it. When y'all done, let me know so I can start.
Done.
I'm done too.
You guys done?
I have the first part. I missed the whole calculating the third. So you can go on.
All right. Anyone else?
I got it.
All right, what you got for M2?
Point 20. Oh, sorry. 0.229.
Anyone else got the same answer?
Yeah.
Yeah.
All right, we're gonna go over it. Where you go? I lost the thing. Give me a second. Hold on. I lost the question.
29.
No, I lost the question. Give me a second. Was it this one? All right, so we have M1, which is 0.445 times 2 equals 3.88 x. I times these two together. 0.445 times 2, we get 0.89 equals 3.88 x. Then I divide by 3.88 on both sides. And then x equals, I say 9. Okay. Point 229381443. Or as what Henderson says, 2.99. 2.29, sorry. And then from there, that's what I get from my molarity. The thing I was saying about this questions, yes, it mentioned 3 solutions on purpose. They only want you to find this. Anyone catch that?
I didn't catch it before, but I see now.
Yes.
I caught it.
So yeah, they mentioned 3 to confuse you, to throw you off, but they only wanted this thing. I was looking for another question that had the same thing like the first one. I think that'll be number 28. Let me see. Yeah, another one for about 27 was 28. You guys want to do that one or skip ahead? You guys understand this part?
How do you find MV3?
How do you know there's MV and M3 or a third solution?
Mm-hmm.
You should do 28.
We should do 28. Okay.
So Johnny, to answer your question, to find the volume, the volumes are additive, so you can just add V1 and V2 together.
Okay. Thank you.
Oh, that was your question?
Yeah.
Yeah, sorry.
Okay.
So would you, I don't know if you remember this, when you come to 3 solutions, volume 1 and volume 2 can be added to get volume 3. Moles of the first solution, moles of the second solution can be added to and you get the mole of the third solution. Molarities are the only ones that cannot be added.
Gotcha.
Okay, so for this question, how do we know there's a third solution? Well, it says it right here. A 40 milliliter volume of 1.80 molarity of FeNO33 is mixed with 21.5 milliliters of 0.808 molarity of FeNO33. So right there, just telling you it's mixing in with this other solution. And then it says calculate the molar concentration of the final solution. Concentration is just another name for molarity. So it says it right there, calculate the molar concentration of the final solution. So it's when you mix 2 items together and you get a third solution. That's how you can tell, or you can't, or you don't understand.
So this is the same thing.
Yeah, it's the same thing as 27.
So this is asking us to calculate M3.
Yes, now this one is asking you to calculate the molar concentration of the final solution. Yes, M3.
So how do you calculate the molarity?
How do you get
of the
molarity?
finals? Oh, okay.
It's just it's like, I say it like this. I'm a bad drawer, so each one is a flask plus another flask. And you get another, same thing, another flask. What we're mixing is a substance. Well, let me use a different color, the easy one.
It's like we
Red.
mixed HCl yesterday and then magnesium, and then we stir it up, remember? And we got a different thing, and then we had to heat it up, like in lab. Kind of like
So
that, right?
Yeah, like that. We get a solution. So the first solution is this, the second solution is this. We add them together, we get this. So molarity would be the molarity of the color red, the concentration of how much red is in here. And the concentration of the yellow in here will equal the concentration of orange. Not red, not yellow, orange. Basically, the pairs. That's what the final solution would be. So when I say mix, you're mixing this, and you get this. This is your final solution. Every time when it talks about mixing, you're mixing one thing, you're mixing another, and they say what calculate the final solution will be this, number 3. Sounds like you guys still confused.
I'm trying to process it. So they're giving us M1, they gave us V1, M2, V2. We need to find M3, and volume V3 is equivalent to the addition of V1 and V2. right?
Do we have
Yes,
to do
So
three-
V3 equals V1 plus V2,
yes.
okay? So then
What?
to get M3,
V1 plus V2 equals V3.
okay, so now how would we get M3?
How do you get molarity? This is its own thing.
So molarity is mole divided by volume.
Yeah.
So we need to get the mole.
So we need to get the moles. So this is like a 3-part problem, right?
Mm-hmm.
Yes.
So to get the moles,
Okay.
got it.
It's almost like stoichiometry. Almost. But you're not dealing with ratios. You're dealing with the actual mole.
So we need to get the GAW for these.
No GAW.
No?
No.
Okay, so now you definitely
The only
confused me.
time you need a GAW
we have
is
to
when
get
you're
the
turning into
mole.
grams. Yeah, how do you get the mole? Remember the 2 ways to get moles? The first way,
Yeah, this is grams over grams per mole.
that's the first way. Grams, to get the mole would
M
be
times volume.
Oh.
grams divided by G mole, you get mole.
Oh, so just 1.80 times 0.04.
What's the other way?
Molarity times volume.
Right, so 1.80 times 0.04. And then 0.808 times 0.0215, and then that equal together, that equals M3.
The moles of each, yes. We equal N3. Did you find see that's why I wanted to do the list. What was your M1?
My mole one
Yeah. Molarity one.
times 0.04, 0.072.
Molarity one is 1.80 with a volume of 440.0 ml.
Oh, I
That's
did,
that's the first solution. That's this bottle. The next bottle,
yeah.
I'm gonna use yellow. It says molarity is 0.808.
I was still using liters.
Yes, you're supposed to. And then we get 21.5. What is it? Milliliters? Yeah. You gotta turn it into liters.
So I got 0.072 for mole of solution one. And N2 is 0.017372. So for N3, I got 0.089 molarity.
Which volume do you use?
I converted it to liters.
Right.
Oh, wait. So that's my N1 and N2 together, but I missed a step, right? Yeah, so then it's 0.89 would be divided by volume 3.
How did you get 1.80 for M1?
They gave us that.
That's in the question.
Oh, that's in the question. Okay.
Yes, 40.0 molar volume of 1.80 molarity.
Oh, I can't read.
Okay, so now I have my N1, now I have my N2, and I just add them together.
But for V3, you would do N1 plus N2 so that your N3 would be divided by V3.
M3 divided by V3 to get the moles.
Excuse me. Well, we need M3, right?
Yeah, we're looking for M3, yeah.
So we have N1, so mole 1 and 2, we added that together. So then we would have to multiply that figure. We would divide by V3 to get M3.
So we divide V by V3 to get M3, yeah.
Okay. So after you add the 2 moles, that's considered mole 3. So
Yep.
mole 3 would be divided by V3.
Yep. That's the mole right there. And we do the same thing with the volumes.
So 0.089372 would be divided by 0.0615, which is V3.
Point 0.04 plus 0.0215. 0.0615. Divide. 937. 2 divided by 0.0615. So you do 0.089372 divided by 0.0615. And your molarity is this.
1.45.
1.4532, yeah, 1.45. 0.3252. We just take the 3 sig figs because that's all we've been doing throughout the whole time. 3 sig figs. 1.45 molarity. Wait, no, that's the yeah, that's the molarity. Because the volume was 0.0615.
David,
It's around liters, so we don't need to do anything about it. Unless it's asking for milliliters, but it's still the same answer. This only works in liters. Yes.
what units we put after that? The 1.45, because we could do all this and then don't put the unit here, just mark it like partially wrong. So what unit do you put after 1.45? Molarity?
Yeah, we're doing molarity.
Okay.
This one here is mole. This one here is liters. So that's how mixing works with dilution. That's dilution with mixing. So just like a simple step of conversion, like which direction do you go?
But he said he wouldn't give us 1 with 3 on the test.
Yeah, I think he said
Thankfully.
that.
Yeah, I
Is
asked
dilution definitely on the test?
yes.
Oh, okay.
I
This was
asked.
one of the, I think this is one of the questions that he was scratching his head on.
Yes, yes.
But I figured it out. I'm like, oh, okay, let's see what they mean. All right, so I'm gonna jump ahead to, I'm gonna jump around now. So I'm gonna do number 34. What is the concentration of 25 milliliters of solution that has 0.05 moles of solute dissolved in it?
I'm sorry, you
So
said 34?
yes, question 34.
Okay. All right, sorry.
So do you guys see what kind of question this is?
Yeah. So
What is it?
concentration is M, molarity.
M, molarity. What else?
M1, like we're using. What is the concentration?
How many flasks are we using?
1.
Yep, only one.
So this is a molarity question.
Yes.
So we're doing M equals, convert the milliliters to liters. So we're doing 0.05 divided by 0.025. Milliliters, right?
Yep.
So it's 2. M equals 2.
M equals 2.
I say this with no certainty.
No, I just, okay, here's the thing. Here's the thing about what I just realized, that
Yeah, it's 2.
let me tell you something that I just realized from what my niece told me about this math trick that happened. When you're dividing decimals, the answer will be a whole number, a big whole number. And when you multiply decimals, it will be a small number.
Oh. Yep.
So I couldn't, that's why when you said 2, I'm like, no way. So it makes sense. That's a cool trick. So there you go. Another fun fact about math numbers.
Because we love numbers.
Well, good thing you guys not taking Chem 2. Chem 2 is worse.
Amen to that.
All right.
Just
So next,
remember, David, the sphenoid is a backbone and skull. Okay.
it's the backbone of the skull.
The bat, B-A-T, in the skull, in the frontal lobe.
Yeah, my professor said it looks like an owl. So
No, okay. Let's fuck with you. Continue.
all right. So let's do 30. What kind of question is that?
You said 30.
Yeah.
Isn't it just a normal dilution question?
Yeah. Good job. Why are you doing it? All right, we got the answer.
Not yet.
You want that answer?
Go ahead. I think I got it. So how do you know which, like, how did you know to use 6.929 for B2, not B1?
Or which
Look
way?
at the question.
It doesn't matter which way. It will still get the same thing as long as you're working with leaders. But yeah, is what Henderson was about to say. Sorry to cut you off. It's
What?
Henderson, you can, sorry, I didn't mean to cut you off.
That's cool. It's the how they worded the question.
Got it. By diluting 6.929 mLs. Okay.
Sorry, I have food in my mouth.
It's all good. I had my dinner while on the session too.
You guys got this answer?
Yes, sir.
I got a different one.
What'd you get?
29.68.
Did you multiply these two together and then divide it by this?
Well, it's probably there. I messed up. I'm just looking at it now, but
Want to practice another one?
no, I got it, but
All right.
that's up to everybody else.
Yes,
So
yes, you do that one. Yeah.
You want to do another dilution question?
Yes, please.
Okay. All right, let's do 26.
Gavin, you should be doing these all since you pushed for this test.
I've been doing started that, we call it your practice test, and I'm like, I was doing it on my computer, and then I'm just in a little bit of pain because I got my flu shot today. And dialysis was rough today. I had to go to the ER.
Oh no, I'm sorry.
No, it's cool. It's a part of it. I got emergency surgery on Monday. Well, it's not emergency. It's at the only time they have next. But you gotta do what you gotta do. You know.
You said you're having surgery on Monday?
Yeah, because it seemed like a part of my ports, like turning like keloid, kind of. It's turning. It's
Oh,
really
okay.
hurts. My pressure dropped to 90/50 today.
Oh no.
But David, 26. Awesome, man.
Yeah, 26. Can you guys still hear me?
Can we
Yes.
what?
Yes, yes, yes.
All right, cool. No, because I was putting on my headphones to see if it works. Okay, so Davin, let's start. How do we do 26? What kind of question is it? First thing you got to do is recognize the question before you whip out your tools to attack this problem.
Is this 26 from the questions that's from the practice test or 26 from the textbook?
26 from the practice test.
Okay, 1 second. I'll pull up right now. Alrighty. One second. 26. You got 10 liters out of 1.2 molar KNO 3. So the first section, V1 is 10.
But what kind of question is it?
Potassium nitrate. I would say it's a solution.
Solution?
Yeah.
Well, dilution, close.
It does have molarity because this is what molarity would be with the potassium nitrate.
So if it's a dilution problems, what's the tool you're going to be using?
Not sure.
What's the formula?
Was it M1 plus M2 over V1 just V2? And then we, put each part. So like, for example, M1.
Not over.
No, it's plus M1 plus M2.
Not plus.
M1 times V2.
M1 times V1 equals M2 times V2.
Okay. M1 times V2. Okay.
No, M1 times V1 equals M2 times V2.
Okay.
So this times this equals to this times this. So whatever answer we get here equals whatever answer we get here.
Okay. So
We're doing 26, you said?
We're doing
Yeah.
26, yeah.
Okay.
So 1.2 on M1.
So we're making a list.
Yeah, you can make the list.
All right, what's M1?
M1 is 1.2 KNO 3.
Okay.
And V1 is 10.0.
All right.
And we're trying to find M2, so it's X right there. And 2.5 liters.
All right, so we plug in the formula. Let me write that again.
You said the volume is 2.5 or 0.25?
2.5.
So
Milliliters to liters, we're dividing,
by
There's no
1,000.
milliliters.
There's no milliliters, all liters.
26. Oh, sorry, I looked at the bottom one.
No,
I
it's
was
okay.
looking at the milliliters in 27. That threw me off. Okay, my bad.
That's cool.
That's why
1.2
we're here.
1.2 times 10 is 12. And then we divide by 12 divided by 2.5. Okay. 4.8. Okay, so that's the answer. It's wait. 4.2. That's the answer. And that is molarity.
That is molarity. And it just automatically 2 sig figs because you see, there's 6 figs.
Yeah.
This is not molarity, this is dilution.
Dilution. How do you know it's dilution? Just by looking at the question.
They ask for M1, not M2.
It doesn't matter.
Okay.
It doesn't matter if you do it the other way. This side equals to this side.
Now, when you put the M1, V1, M2, V2, so I think they ask for M1, not M2.
But it's the same way.
Hmm.
You don't see it? If this was on the other side, and this was on the other side,
Okay.
it's the same way. Just look at it like it's a mirror. No matter what, this side has to equal this side.
No, I just say that because if you put M2, I don't know if the professor
Well,
get-
that part is like if you can distinguish it, it would be easier to tell, but overall in the end, it's just it doesn't matter which way you do it, you're still gonna get the same answer.
Yeah, I know.
I'm just simplifying it for you. That's all I'm doing. I'm just making it very simple for everyone to understand. But if you can tell the difference, then use that tool as well. If you can see if it's like you said, if it's asking you for M1, then go for it. Use the same way, it doesn't matter. You still got to divide this by this side, and you still got to get this. Because it doesn't matter if you did this way, we still got to divide this to get that.
All right.
But if you, like I said, if it's easier for you to read it that way, go for it. Use that tool if it helps you. Use all the tools that you can. Sometimes you find tips, sometimes you find tricks, and that's go for it. Use that trick. And I don't know how to explain it, how you can tell the difference between 1 and 2, but it's really all in the question. It's really all in the question because it says there you need to make 10 liters of 1.2 molarity. So yeah, she is right. It was on this side because we need to make this. They're giving us the numbers on this, so we need to make this. What would be the molarity of the solution that we need? We need this to make this. We're making, needing. So I'm gonna put an arrow here, need. When you see questions that said need on this side, to make this side, make or mix. Those words will distinguish which side to use. But like I said, it's really not necessary. You still get the same answer. But if you want to be technical with it, yes, right there. Does that help?
If you put 1.2 times 2.5, you get 3. And then 3 divided by 10.
Why would you multiply this over here?
No, I'm just going by what she's saying. That if you were to put 1.2 on the opposite side.
Just flip the mirror over. It's the same thing.
Yeah.
Because we still got to do this. You see, we're just that it's reflected over,
Reverse, yeah.
and we still get the same answer. This combined together, you get 12. Will be on this side. Still the same thing. We just divide it, and then we get the answer. Doesn't matter. As I said, doesn't matter which way you do it. But if you want to get technical, this is how you tell the difference. They say we need something, that will be A. To make or mix with will be this, B. Final solution, that's like M3, B3. We're talking about final solution, total. Like words like that. Does that help?
Yes.
So number 25, can you tell me how would you distinguish that one? Like what would be 1, what would be 2? Are there 3? Is it 1, 2, or 3?
There's only 2.
It's only 2. How can you tell?
Because it said that if you dilute 175 milliliter of 1.6 M solution of L to 1.0 liters, you have 2 on one side, and then you have to find the LICL.
So do you guys understand that or no? Hello?
Yeah, so David, 25. So
Give me a second. My mom is calling me. Hold on.
yes, sir.
I think I'm gonna log off for the night, guys. I think I've had enough actually. I understand it.
All right,
Sounds
cool.
good.
Don't think my brain can take anymore. Have a good night, everyone.
You too, thanks.
Yep. So for 25, what I was going to do is I'm going to multiply 1.6
I'm gonna
times.
log out after this.
Yeah, me
Oh,
too.
Yeah, I'm gonna. Might as well. Then we could probably link up on Sunday, if we can.
I'm whatever availability. I don't know what David. I know he has a A&P test also.
Yeah, that's right. I'm gonna ask when he come back. So what I did was I multiplied.
Sorry, guys. What happened?
We were just saying that you have an A&P test coming up, and we were saying about the weekend, but we don't know what schedule's like for the weekend.
Yeah. So what do you guys want to do?
It's ultimately up to you. We're free.
You guys are free the weekend?
Yeah.
I mean,
Okay.
Davin, I would also like go back like try to do some of the tests
That's what I'm
and
gonna do.
then
Yeah.
go back and watch
You
this
know what?
video because he went over it a lot. If you want, you can send the test to us and we'll check the work.
All right,
And
that's all.
then if there's something specific that you need more help on, then try to see what fits into his
All right,
schedule
cool.
to kind of,
I'll watch. Yeah, I'll
you
do
know,
that.
work
I'll
that out.
and then I'll also I'll take a test because I like. Okay, because I'm
I
looking at 25.
recommend you do the test first, then watch the video so you can compare your answers.
Yeah, definitely.
Yeah, and then if there's something that you're like really stuck on, then we can try to see, because like I said, I know David, he gets this already and he has a AMP lab test that I'm actually gonna Zoom with him tomorrow to try to help him with that. So
What is it on?
If anyone want to help me study, that'll be great.
Just put a link in. Put a link in there. Put a link in the thing and say if anybody would help me study AMP. I'll join you.
I'm about to go make a test for him for AMP on bone.
All right,
both?
so
Probably do that tomorrow
we're
morning.
calling it done for the night.
Yeah.
I'm pretty comfortable with it. I'm gonna finish the test and then I'm gonna do the same and send it to you.